All right, welcome back to the spring semester. We are in the first full week and we are going to be starting our next unit today, which is entirely about chemical reactions, okay? So we're going to get into some of the basics of chemical reactions today, and then we're also going to work on our first skill associated with this topic. The objective of that skill is for you to be able to classify chemical reactions according to their reactants and products. There are several different types of reactions, and so that is what you're going to be doing today. You're going to be learning about those different types and what makes each of those types unique and how you can classify reactions as one of those types based on their reactants and products, okay? So, like I said, there's some basic information here about chemical reactions to start with. Chemical reactions are chemical changes. So one of the first things we talked about in the fall semester was the difference between a physical and a chemical change. Chemical reactions are chemical changes, okay? And in order for a chemical reaction to have taken place, you have to have formed at least one new substance, okay? So that's what makes a chemical reaction, is the formation of at least one new substance, okay? Chemical reactions are not physical changes such as melting and boiling, okay? So like ice melting into liquid water or liquid water boiling into steam, those are just physical changes because the water is still remaining water. It's just changing from solid to liquid or liquid to gas. It's not a chemical reaction, okay? Once again, a chemical reaction has to create at least one new substance that wasn't there before in order for a chemical reaction to be there, all right? Chemical reactions are represented or written down on paper in the form of what is called a chemical equation, okay? So a chemical equation looks something like this. These are just placeholders, okay? But on the left-hand side, you're going to have what are called your reactants. This is what you're starting with, okay? So your like original ingredients, okay? And then when the reaction takes place, that's what this arrow represents, okay? When the reaction takes place, what you end up with on the other side, those are called your products, okay? And so in this generic equation, C and D would be the products here, okay? And C or D, or both of them, these have to be the new substances that were formed as a result of the reaction, right? So in this sort of generic equation here, A and B are combining, or they're doing something to form two new compounds or two new substances here, C and D, all right? So this is generically what a chemical reaction equation looks like. Now, like I said, there are lots of different types of reactions. We're going to be looking at 5 different types. There's more than 5 types, but we're going to try to keep it a little bit on the simple side. And so we're just going to look at 5 types of reactions, okay? And you're going to learn how to identify those different types or how to classify reactions as one of these 5 types, all right? So the first type of reaction is called a synthesis reaction. Synthesis means like coming together or forming, something like that. So a synthesis reaction looks like this. You're going to have at least 2 different substances that combine together, right? See that plus sign? 2 different substances that combine together into one substance, okay? So I have an example of this for you. Magnesium and oxygen can combine together to make a new substance called magnesium oxide. We would do this in class if we were in class, and when we come back at some point this semester, hopefully, I will show you what this reaction looks like. But basically, magnesium is a metal, and you can light it on fire, and it will burn with oxygen in the air to form kind of a chalky substance, which is called magnesium oxide, okay? So the one thing you're looking for in a synthesis reaction is a single product, okay? Notice how there's no plus signs over here. So a single product on the product side, or on the right side of the equation, signifies to you, or should be your clue, that that is a synthesis reaction that you're looking at, okay? All right, the next type is the opposite of a synthesis reaction, decomposition reactions. Decomposition You guys probably know this, right? Decomposition means like to break down or to fall apart, something like that. So a decomposition reaction is exactly the opposite of a synthesis reaction. One reactant, one thing on the left, breaks apart into two or more separate components. Okay? An example of this is hydrogen peroxide, H2O2. That's the stuff that you pour on a cut or pour on a little wound, and it kind of burns. That it comes in like a black or a brown bottle. That stuff will naturally, over time, decompose into water and oxygen bubbles or oxygen gas. Okay, that's actually why they have to keep it in a black or brown bottle, because light, sunlight, and just light in general will speed up the decomposition. So in order to keep the hydrogen peroxide, keep it together, they store it in those dark bottles so that light can't get to it. So what you're looking for in a decomposition reaction is a single reactant, okay, one thing on the left side of the equation. All right, these next two are a little bit complicated, but they're not too bad. The first one here is called a single replacement reaction. You're going to have two reactants, and what happens here is one of the reactants is an element by itself. The other is a compound. This element is going to come in here and replace one of those elements, okay? And so A and B are going to swap places, right? And you can see on the other side of the equation, after the reaction takes place, A comes in and kicks out B, okay? So it's like we end up with AX and then B by itself. You can think of this as kind of like, I don't know, somebody who's single, I don't know, gets like a friend of theirs to like break up with somebody and now they're with them instead, okay? So like A was the single person and B was in a relationship and A kicked out B and now A's in the relationship and B is single, okay? So that's kind of one way you can think about it, all right? That's a single replacement reaction. The example, as you can see here, we have aluminum. It's going to come in and replace hydrogen, okay? And so hydrogen is going to get kicked out. So aluminum is with the chlorine now, and hydrogen is by itself. All right, so that's what a single replacement reaction looks like. The next one is very similar to this. It's called a double replacement reaction, okay? And it's basically the same as a single replacement, except here we have two compounds. We're still going to have the swap, though, okay? So A and B are going to swap places, okay? So A was with X, B was with Y. Well, now A is with Y and B is with X, okay? So that's what a double replacement reaction looks like. So in this situation here, we've got potassium is going to swap with lead. K is going to swap with Pb. And so K is with the NO3, and Pb is with the I. Okay, those are the products there. All right? We will definitely practice with this quite a bit, because these two, the single and double replacement reactions, these are the ones that students typically have the hardest time working with. Okay? Synthesis and decomposition are pretty easy. Single and double replacement are a little bit harder. So we will definitely practice this a little bit as we get started on your assignment for today. All right, and then combustion. This is the final type of reaction. This is the easiest of all to identify, and that is because combustion reactions always have these three ingredients. Okay, always. You're always going to have O2, oxygen, CO2, carbon dioxide, and H2O, which is water. Okay, those three things are always going to be there, always. The only thing that can change in a combustion reaction is the fuel, whatever it is that you're burning. That's what combustion means, burning. So fuel is going to be some combustible chemical, some sort of, usually a hydrocarbon, meaning it's got hydrogen and carbon in it, something that you're going to burn. Okay, in this case over here, it's methane, CH4. All right, what you're looking for in a combustion reaction is these three things. Okay, if you see these three chemicals in this order, it is going to be a combustion reaction pretty much every time. Okay, so like I mentioned at the beginning, the objective here is for you to be able to classify chemical reactions as one of these 5 types. Okay, and so that's what you're going to be working with. You're going to see lots of these chemical equations, like this one here and like this one here, and it's going to be your job to pick which of these 5 reaction types it is. Okay, We will get started on your assignment together in class right after this video. All right, thanks for watching.